Hey everybody, hope everybody's hanging in there. This will be our first video for Algebra 2. It's Monday, we're in here kind of trying to navigate our way into what these videos are going to look like and how they're going to help you, and just exploring all kinds of possibilities and avenues. So again, if there's stuff you need from us, please feel free to email anytime. We'll get back to you and we'll talk more about office hours and some other things, but real short video, what I want you to kind of work on, and hopefully you're writing some of this down and you follow along with me. Again, just to kind of continue off of the things we discussed right before you left, okay? So we were dealing with large degree polynomials. We know if it's a fourth degree, we need 4 roots, okay? If we graph this, we would not see it hitting 4 times, which is kind of where we left with last week. We would only see it hitting twice. We would see it hitting once at +1, let me double check this. Yeah, -1 and +3. Okay, so if you plug that in your calculator, you should see it hitting those 2 points on the x-axis. Now, to take those out, we did 3 things. We did synthetic division, which is the very last thing we did. We did long division, and we also did our area boxes, okay? Now, to keep it short today, I'm going to do synthetic, just because it's quicker, but I encourage you to go back and review the other 2 methods just to make sure. But again, no matter which method you choose, it should give you the same answer every time. Okay, so -1, I believe, is that what I said? Yes, -1 is going to be our first root that we're going to take out, factor out. So then we list the coefficients. So 1, 2, -6, -22, -15, okay? Bring down that first one, -1 times 1, -1. 2 minus 1 is 1. -1 times 1 is -1. -6 times -6 minus 1, excuse me, is -7. -1 times -7 is +7. -22 plus 7 is -15. -1 times -15, +15, and 0. And we know if it's an actual root, we should get a 0 remainder, which is good. So we took out really this, right? And we're left with, remember, we just work our way backwards. Whole numbers, x's, x squareds, x cubed. So this would be left with x cubed plus x squared minus 7x minus 15. Okay, so that was taking out that x plus 1 root, or -1 root, okay? The other one we said was a +3. Now I don't want to take +3 out of our original, I want to take +3 out of this. So then I'm like I said, you're actually taking pieces away. So let's take out a +3. This is going to be 1, 1, -7, -15. Sorry, that's a 5. Just trust me. Bring down the 1. 3 times 1 is 3. 1 and 3 is 4. 3 times 4 is 12. -7, +12 gives me 5, right? Positive. 3 and 5, 15, 0. Again, good, right? So we took out that original -1. We took out then a +3, and we're left with this. Again, whole numbers, x's, x squared. So we're left with x squared plus 4x plus 5. Okay? Now, if we got back to this quadratic, we could then just use our x method to factor it or however we want to, but is this factorable? And that's a big no, okay? We could think, okay, 5 and 1, but there's no way I can do 5 plus 1 or -5 minus 1. They're not going to give me to a +4. So we have 2 real roots and then 2 non-real roots, okay, because they're not hitting the x-axis, right? So what do we do with non-real roots? We can't factor it, so we must use quadratic formula. And I'll kind of give myself a little box over here. So quadratic formula, negative b plus or minus square root b squared minus 4ac all over 2a. Okay? Again, we're just worried about this part right now. So a value is going to be 1, b value is 4, c value is 5. So negative b would be negative 4 plus or minus square root b squared, which would be 4 squared, 16, minus 4ac. So 4 times 1 times 5 would be 20. All over 2a, which is just going to be 2. Okay? Again, I kind of simplified that quickly. If you have, discrepancies or questions, please, email me or look back at the video or try it a couple times. But again, we're just trying to find the two missing roots using quadratic formula. So let's go negative 4 plus or minus square root. This ends up being negative 4 over 2. Now we know we can't take the square root of a negative, but what we can do is we can take out that negative 1 in the form of an I. Now I know we glance on this briefly, but here's what it essentially looks like. We just take out that negative 1 and then the 4 becomes positive. Negative 1 becomes I. What's the square root of 4? 2. This becomes a 2. So are there any radicals left? No, so it just becomes 2i. So this becomes negative 4 plus or minus 2i over 2. Now, are both of these divisible by 2? Yes. So then we can divide them both by 2. So it becomes negative 2 plus or minus I over nothing. So the two roots would be negative 2 plus I, negative 2 minus I. So our 4 roots, 1, 2, 3, and 4. Those would be our 4 roots, okay? So again, we're still factoring polynomials. We're still using the 3 methods we talked about: synthetic, long division, area to area boxes. However, when we get to certain things that are non-real, we have to explore different options like quadratic formula, okay? And I can almost guarantee you when you have non-real roots, you're gonna have to deal with I. You're gonna have to deal with a negative underneath the radical, okay? There will be some irrational ones when you have to use quadratic formula, but it's real. They just end up with stuff like this that's just not quite factorable, okay? But again, hopefully that helps out. I'm gonna provide a couple more examples I want you to try. My recommendation would be take the polynomial, try one method, try area boxes, then try long division, or do the whole problem different ways, right? Try the whole problem using synthetic, try the whole problem using long division if you like, okay? I know people are gonna prefer different things, but it's important that you at least see all of those options depending on how it'll, how somebody will address it different in the future, okay? Again, hopefully that handles day 1. I'll give you a couple more options. I'll post them for you. Just again, try those up, and if you have any questions or need anything, please feel free to let us know. And hopefully we'll see you here in a couple weeks or so, okay? Take care, bye.